Welcome to OPStudio by OpenPhase Solutions. In this quick tutorial, I'll show you how to simulate normal grain growth using custom presets. We'll go step by step from setting up the model to running the simulation and visualizing the results without writing any custom code. Before discussing the numerical setup in OPStudio, we first need to understand how the phase field method describes individual grains and which parameters control grain growth. In this framework, each grain is represented by its own phase field variable, and the evolution of these variables governs the motion of grain boundaries. Phase field variable takes the value 1 inside that grain and 0 otherwise. For example, if we follow the line scan, the red phase field is equal to 1 inside the red grain and 0 everywhere else, which is similar for other grains. As we move across a grain boundary, the phase field variable does not change abruptly, but instead varies smoothly from 1 to 0, reflecting the diffuse interface description of the phase field approach. The interface width can be controlled in OPStudio. Moreover, the interface energy represents how energetically expensive the grain boundaries are. The mobility parameter, on the other hand, determines the kinetics of grain boundary motion, meaning it controls how fast the grains grow. In order to do a normal grain growth simulation, we open OpenStudio and then select Custom Project. We don't need some thermodynamics and we don't need mechanics for a normal grain growth simulation. We just click here on Finish, and then we are greeted by the periodic table. We need to select any element, so let's take iron. And then we create a solid phase, and we click on Apply, and here we can select Simulation Title. Total simulation step is set to 10,000, with the output to VTK after every 100 time step. And each time step would, let's say, 1e-1. And the number of OpenMP threads that we use, let's say 4. That depends on your processor. In boundary conditions, we don't need to change anything. Here we can select an interface width of 5. We take a grid spacing of 1e-7. The box size will be 100 times 100 times 100 grid points. The interface properties, we select an interface energy of 1. And then we select an interface mobility of 1e-14. So this is basically everything we need to select. And then we need to select Voronoi for initializing the microstructure. So we delete the single and then select a Voronoi tessellation. And then we can select the number of grains, let's say 280. And then click on Apply. And then we can start the simulation. So it will ask you to save the input. It will take your name that you gave the simulation and save it, and then it will start. To visualize the simulation output, which was saved in the preset folder, open ParaView. From the VTK directory, load the phase field files for this simulation. It will load the files, then click Apply. Next, you have to select phase fields, and then choose Surface from the drop-down. Now go to Filters and select ISO Volume from the alphabetical drop-down. For the input scalars, select Interfaces. Adjust the cutoff values by setting the minimum to 1 and the maximum to 1.5, then click Apply. Finally, reselect phase fields from the drop-down and click Play. These are the final visualization results of the simulation. If OPStudio fits your workflow, download the free trial or explore the licensing options on our website. Subscribe to our YouTube channel for more technical tutorials. Thank you for watching.